Okay, everybody. We just got a little quick question here about finding the second derivative implicitly. So first thing I'm going to do here with my expression x equals y cubed plus y is I'm going to find the derivative, the first derivative. The derivative of x is just going to be 1. The derivative of y cubed is going to be 3y squared multiplied by the derivative of y, because I don't know what that function is. I don't know what function y represents, but I know that the derivative fits there. Plus the derivative of y is going to be 1 multiplied by the derivative of y, that function there. Because remember, this is sort of like the chain rule, where y represents some interior function. I don't know what it is, but I know that I have to multiply by its derivative. So now what I'm going to do is I'm going to factor out that y primed, and I get 3y squared plus 1. And I would solve for y primed, and I'll get y primed is equal to 1 over 3y squared plus 1. And actually, for the sake of what I'm about to do here, I'm going to write this as 3y squared plus 1 to the negative 1. Now I'm going to take my second derivative, and I'm going to take it of this bit right here. So that's going to be negative 3y squared plus 1 to the negative 2. Okay, so I brought down the exponent, reduced it by 1. Now I'm going to multiply by the derivative of the interior here, which is going to be 6y multiplied by y prime. I was about to say y squared, but y prime. So I'm applying implicit differentiation to the interior of the function here, just kind of like the chain rule, and I include the y primed. Now, here's the thing. You really don't want to express a higher derivative in terms of a lower one. And I really don't need to, because I already know that y primed is equal to 1 over 3y squared plus 1. So I can make a substitution. So what I'm going to do here is I'm going to make this, first of all, I'm going to take that first expression, I'm going to write it as negative 1 over 3y squared plus 1 squared, multiplied by 6y, and then I'm going to multiply that by 1 over 3y squared plus 1, because that is what y primed is equal to. And now when I put that together, my numerator is actually going to be quite simple, negative 6y over, and in my denominator, I'm going to have 3y squared plus 1 squared times 3y squared plus 1. So over 3y squared plus 1 all cubed. And that would be the second derivative that I'm looking for.